Let's talk about homogeneous systems. A system of linear equations in the variables x1, x2 up to xn is called homogeneous if the constants on the right-hand side are all equal to 0. In other words, each equation in the system has this form: a1 times x1 plus a2 times x2 plus all the way to an times xn equals 0. We note that every homogeneous system has at least one solution, which is when all the variables xi are equal to 0. This is called the trivial solution. What we are more interested in, however, is a solution in which at least one of the variables x1 up to xn is non-zero, and such a solution is called a non-trivial solution. We can observe the following fact. If a non-trivial solution exists for a homogeneous system, then there are in fact infinitely many non-trivial solutions for the system. This is true because from the previous video, we know that a system of linear equations has no solution, a unique solution, or infinitely many solutions. Since a homogeneous system always has the trivial solution, the existence of a non-trivial solution implies that there are at least two solutions for the system, so it must have infinitely many solutions. In this case, the general solution consists of the non-trivial solutions plus the trivial solution. So the question to ask now is, when does a homogeneous system has non-trivial solutions? The following theorem gives us a sufficient condition for a homogeneous system to have a non-trivial solution. This sufficient condition is that the homogeneous system has more variables than equations. This can be illustrated by the following simple example. Let's consider the equation x plus y equals 0. We have only one equation, but two variables, x and y, and we know that the general solution to this equation is negative a, where a is a real number. Notice that we have the trivial solution when a equals 0. So, the non-trivial solutions are negative a, when a is a non-zero real number. Let's try to prove this theorem. Suppose there are m equations and n variables. Since we assume that there are more variables than equations, we assume that n is greater than m. We also let the coefficient matrix A to have rank r. That means that there are r leading variables and n minus r free variables, hence n minus r parameters. It suffices to show that r is less than n, because it means that there is at least one parameter, and so the system has infinitely many solutions. Now, since r is the rank of A, we know from the previous video that r is less than or equal to the minimum of m and n, which is less than or equal to m. By assumption, m is less than n, so indeed r is less than n, and the proof is complete. Let's look at an example to find a non-trivial solution to a homogeneous system. As before, we reduce the augmented matrix of the system to row echelon form. However, this is not as smooth as before, because we see that none of the leading entries in the three rows is equal to 1. So we have to first multiply the first row by negative a half to change the leading entry to 1, unavoidably creating fractions in the later entries. As the next step, we subtract 3 times the first row from the second row and add 5 times the first row to the third row, and obtain the following matrix. At this point, we observe that the third row is equal to the second row times negative 1, so we add the second row to the third row, so that all the entries in the third row become 0. We also multiply the second row by 2 to eliminate the fractions. Now this matrix is in row echelon form. The second row means that x2 plus 11 times x3 equals 0, so we set x3 equals a to get x2 plus 11a equals 0, so x2 equals negative 11a. Then we put x2 and x3 in the first row to get x1 minus 3 halves times negative 11a minus 3 halves a equals 0. So x1 equals negative 15a. Hence, the general solution is negative 15a, comma negative 11a, comma a, where a is a real number. Now, a particular non-trivial solution can be found by substituting a non-zero value of a into the general solution. For example, if I substitute a equals 1, we get the non-trivial solution negative 15, comma negative 11, comma 1.